Assalamualaikum students, and our today's topic is the combination of resistors. So just like in the case of capacitors, you can just take resistors, two or more than two resistors, and connect them either end to end or in the form of branches. Okay, either you can connect one end of one resistor to the other end of the other one, or either you can take all the similar ends of one resistor and connect them and connect the other terminals of all the resistor at one point to make a junction. Okay, so when two or more than two resistors are connected together in an electric circuit, the arrangement causes change in voltage or current. This type of assembly is called the resistor. This type of assembly of resistor is called the combination of resistors, of course. Okay, so basically whenever we connect them resistors either in series or in parallel, they affect the amount of voltage or the current passing through that electric circuit. So that is the reason why we connect them, physically in different kind of arrangements. Okay, so arrangement actually has very important role in our electric circuits, right? So the first thing that we are going to discuss today is the series combination, and we will discuss the parallel combination in our lecture. The series combination, as the name suggests, as we've already studied about the series combination of capacitors, when resistors are connected end to end and there is only one path for the flow of current through that wire, then this type of assembly is called the series combination of capacitors, right? So अब हम देख सकते हैं, this is the first diagram that I have drawn over here. These are, of course, my drawing is not really good. These are the LEDs, or you can say bulbs, small bulbs over here, and I have connected them to my battery. So you might think कि मैंने यहाँ पर bulbs क्यों लिए and मैंने resistors क्यों नहीं लिए, because मैंने आपको पहले ही बताया है this is the symbol of resistor. Then why did I take just a small LED bulb over here? Because any electric device which uses the potential energy provided to us is called resistor. LED bulbs, जो छोटे वाले bulbs होते हैं, आप लोगों ने देखे होंगे, that is also called as resistors because they use that potential energy provided to them. Okay, so whenever they with whatever kind of electrical component that uses the electrical energy that is provided to them, thus producing a potential difference across themselves, is called resistors. Okay, so resistors जैसे मैंने आपको draw करके बताए थे, फिक्स रजिस्टर एंड वेरिएबल रजिस्टर के फॉर्म में, वो भी रजिस्टर्स हैं. एंड एनी काइंड ऑफ डिवाइस जस्ट लाइक एलईडी, मैंने इसीलिए यहाँ पर एलईडी बनाया ताकि ये शो करे दैट देयर आई हैव यूज्ड दीज एलईडीज एज resistors, right? So this is the first diagram to show that LEDs are also resistors. Now coming to the second diagram, which is the most important one, and I have taken three resistors over here just like I did in the case of capacitors. यहाँ पर हमने क्या किया, three resistors लिए and उनको end to end connect किया. What does it mean? It means that the right end of first resistor is connected to the left hand of second resistor, and the right hand of second resistor is connected to the left hand of third resistor, and in turn the left hand of the first resistor and the right hand of third resistor are connected to the battery, right? So what happens is that whenever I switch on my battery, current will start to flow in this circuit. We take this conventional current. Okay, हम conventional current लेते हैं, आप चाहें तो electronic current भी ले सकते हैं, right? So for conventional current, I will go from the positive terminal to the first resistor. You might notice that there is only one path for the flow of current. Current can't go anywhere else. It will just follow this path and terminate at the negative terminal. Okay, so the current at the start that leaves the battery is equal to the current in the first resistor is equal to the current in the second resistor, and in turn this current is also equal to the current in the third resistor. So basically यहाँ पर सर्किट के हर पॉइंट पर करंट सेम होगा, बिकॉज यहाँ पर हमारे पास करंट के फ्लो के लिए जस्ट वन पाथ है. Okay, so we take this equation and we call that equation number 1, which is I equals to I1 equals to I2 equals to I3, and the total potential provided by the battery, okay, is the potential difference across R1, R2 and R3. Okay, so बेसिकली जब हमारे पास करंट चेंज नहीं होगा देन वोल्टेज चेंज होगी. वोल्टेज क्यों चेंज होगी? बिकॉज यू माइट सी इस पॉइंट पर जो एनर्जी है इस पॉइंट पर वो एनर्जी नहीं होगी. ओके, देयर विल बी सम काइंड ऑफ एनर्जी डिफरेंस ओवर हियर बिकॉज कुछ एनर्जी ये रेजिस्टर भी यूज़ करेगा. सिमिलरली at the energy at this point is different from the energy at this point because कुछ एनर्जी ये वाला रेजिस्टर भी यूज़ करेगा एंड कुछ एनर्जी ये रेजिस्टर भी यूज़ करेगा. जब एनर्जी डिफरेंस क्रिएट होता है तभी पोटेंशियल डिफरेंस भी क्रिएट होता है, राइट? सो द डिफरेंस ऑफ पोटेंशियल एनर्जी creates a potential difference over here, and that potential difference can be written as del V1. हमने यहाँ पर V1 नहीं लिया because V is just for the battery. V can be taken as for one point only. V हम जब भी लेंगे किसी एक point के लिए लेंगे, but जब भी हम किसी दो points के दरमियान V लेते हैं then that is not actually V, that is del V. ओके, सो दो पॉइंट के दरमियान अगर लेंगे तो del V लेंगे, विच इज डिफरेंस ऑफ पोटेंशियल बिटवीन दीज टू पॉइंट्स. सो द टोटल पोटेंशियल provided by the battery is equal to the potential drop across the first resistor, the potential drop across the second resistor, and the potential drop across the third resistor. Okay, so हम यहाँ पर देख सकते हैं del V equals to del V1 जो कि इस रेजिस्टर के अक्रॉस पोटेंशियल ड्रॉप है प्लस del V2 which is the potential drop across this resistor and del V3 which is the potential drop across this resistor. Now what are we going to do? Simply we are going to use Ohm's law over here. Ohm's law say that R is equal to del V divided by I. Okay, यहाँ पर हम just V नहीं लेंगे, del V लेंगे because हम यहाँ पर potential drops ले रहे हैं. So R is equal to del V by I and del V equals to I R. हमने del V की वैल्यू इसलिए ली बिकॉज हमने इसे इक्वेशन नंबर 2 में पुट करना है. सो वी नीड द वैल्यू ऑफ del V. ओके, सो अब इसी del V की वैल्यू को हम थोड़ा सा मॉडिफाई करेंगे अपने फर्स्ट पोटेंशियल ड्रॉप के लिए, सेकंड पोटेंशियल ड्रॉप के लिए, थर्ड पोटेंशियल ड्रॉप के लिए, एंड फॉर द इक्विवेलेंट पोटेंशियल ड्रॉप विच इज़ अक्रॉस द बैटरी. ओके, सो फॉर del V1 equals to IR1. I के साथ हमने 1 इसलिए नहीं लिखा because all these currents are the same. So that's why we have taken just one I, which is simple I. So del V1 equals to IR1, del V2 equals to IR2, del V3 equals to IR3, and del V equals to IR equivalent. Okay, so for the whole potential difference, R becomes R equivalent because we have to replace these three resistors with its equivalent resistance over here. Okay, so putting all these four equations in equation number 2, we get del V की जगह IREQ which is R equivalent equal to del V1 की जगह IR1, del V2 की जगह IR2, and del V3 की जगह IR3. Now we can just take I common over here. Okay, हम लोग I को common लेंगे so that I को common लेने के बाद हमारे पास ब्रैकेट के अंदर R1 plus R2 plus R3 बचेंगे. IR equivalent equals to I into R1 plus R2 plus R3. I and I would cancel each other and as a result we will get R equivalent equals to R1 plus R2 plus R3. Simple. You might notice that this is a kind of equation that we had obtained in the case of parallel combination of capacitors. But for the resistor, we will obtain this kind of equation for the series combination. So, For the three resistors connected in series, their equivalent resistance will be equal to R, the sum of these three resistors, and that sum of three resistors will be equal to Req. Req is the resistance जिसे हम अगर डायरेक्टली बैटरी से कनेक्ट करें तो वो एग्जैक्टली वही रेजिस्टेंस देगा जो कि ये कंबाइन होकर दे रहे हैं. ठीक है, दैट इज़ वाई दीज टू टर्म्स आर इक्वल टू वन अनदर. बट अगर आप चाहें तो आप 3 रेजिस्टर्स की जगह 2 भी ले सकते हैं, 4 ले सकते हैं, 6 ले सकते हैं, जितना चाहे ले सकते हैं. सो फॉर एनी नंबर ऑफ रेजिस्टर्स, फॉर n number of resistor, Req becomes equal to R1 plus R2 plus R3 up to Rn. जितने भी रेजिस्टर होंगे सिंपली हम उनके रेजिस्टेंसेस को एड अप करेंगे एंड देन वी गेट द final equivalent resistance, right? So these are the two important equations for the series combination, and that is how we can just calculate the equivalent resistor for the case of series combination. Thank you so much, everyone.